So, hi everyone, thanks for joining us today. Today we will talk about developing a game for PSP, and we will focus more on how it can be done today in 2025. That's why we called our presentation development with the modern tools. Yeah. So my name is Dmitry, and this is Ivan. We both work as software engineers. We both work as software engineers, and building games for PSPs is just our hobby. This talk is not going to be a very technical deep dive into development games for PSPs, but rather serve as an inspiration for others to try. It's not hard today, and you will see why. So here's the QR code for this presentation for those of you who likes to follow the presentation on their own devices. And we numbered every page to reference in the Q&A section. So yeah, at the beginning of my career, I worked as a game developer, and I worked in very small game development studios. Together with my friends, we created our own game developing studio, and we failed to make it profitable and moved on to other opportunities. But around this time, we decided to start to join Ludo Dare contest, and it's a game jam when people are required to create game in 2 or 3 days for the given theme. And there are two main parts of Ludo Dare contest. They are compo and jam. In compo, people participate individually, and in jam, they participate in teams. And when you are participating in a team, you need to create a game in 3 days, not in 2. That makes a lot of sense, right? Yeah. So that's actually answers to your question why it's so strange. It's for Ludo Dare contest. It should be strange. So yeah, Ludo Dare contest is very short. It's 2 or 3 days, and we participate as a team, and it's 3 days for us. So games for Ludo Dare are usually not that very complicated. There are always some exceptions, like every contest has some exceptions, so you can see 1 or 2 games that are 3D, but majority of them are in 2D. So here you can see screenshots from our entries, not from every entry, but the most beautiful ones. I placed our first game here, and it's actually me. Yeah, in the past we developed games targeting personal computers, macOS and Windows platforms, and it was okay in the past. So we started in 2013, so it was okay. But now the security of a new operating system growing and growing and growing, and now it's really hard to make people to run your game on the PCs, because for example for macOS and for Windows we don't assign binaries, and on macOS you need to first launch the game, then go to settings, find security and privacy settings, okay, allow like everything, then launch a game again, and it will ask again, are you sure? It's so scary. So it's really hard to make people to run your game if it's be built natively for PCs. But it was a well-established process for us. We used our own game development engine, and there were no surprises, and we needed a change. So 2 years ago, we decided to challenge ourselves and develop for Playdate. So there will be a really interesting talk after our talk here in this room about Playdate. So I think that it will be very interesting. So we decided to pick Playdate as our target platform. But by that time, not that many Playdates were sold. But it doesn't mean that we reduces our chances for being played, for people to play our game, because the ecosystem provides a really nice simulator which is available for macOS, Windows, and Linux. Yeah, Linux too. So people can use this very trusted simulator, signed, everything is okay, and run our game on their own PCs. So it went quite well. We got enough players, we got enough ratings, and there was even one person who ran our game on a real hardware. So we read this in the comments. It was really nice. Yeah. So yeah, this is how this game looks like. Playdate has a monochrome screen, so no surprises. There are no colors. And yeah, we developed this game in the public GitHub repository. So if you want to see the code, you can. Yeah, and this year we decided to challenge ourselves even more and develop a game for PlayStation Portable. Yeah. Actually, there are tons of different ways how people can run your game that is developed for PSP. They can run on real hardware, and there are tons of PSP sold since 2004. So for example, this one is 20 years old, and this is my own device, and it's in pretty good condition, right? They can use emulator and run the game on the PCs. They can use emulator and run the games, the PSP game on their mobile phones. They can use emulator and run the game on Steam Deck. So we have Steam Deck here.
It's
what?
It's Asus.
Asus, okay, but it's the same. But the problem was that we didn't have any PSP related code. So we decided to start a little bit in advance. We started like a month in advance before the contest to develop some common parts. We don't call it a game engine because it's not an engine. It's a collection of libraries. It's a collection of utilities that we can use to build our game. But it means that you don't have to wonder how these guys were able to build that many things in 3 days. No. In 3 days we developed only a game, but we prepared for a month. Yeah, and again, this one was developed in the public GitHub repository. Feel free to have a look. Yeah. So there was only one official way that people can develop for PSP, and it was tough. So only mid-size and big-size studios can go that path. And it was you first contact Sony and asking for a dev kit. You need to prove that your studio is capable of delivering the final product. Then you receive a dev kit, develop, and it was really hard to back then. Then you go through a lot of Sony's reviews. Then you publish your game. Bravo. but now there is no official way to develop for PSP. But so soon after PSP was released, hackers started to find exploits in firmware to allow launching the unsigned code on the devices. And there was a very big and very strong community of hackers and developers who laid a very strong foundation for the homebrew movement. And actually, the idea of the homebrew is not piracy in the first place. It's more about the freedom. It's about research. It's about allowing users to use their purchased devices the way that they want to launch anything. So that's how it started. And now there is a very major ecosystem of SDKs, emulators, tools, libraries. That was built from this homebrew community. I will touch base on two main parts of this ecosystem, and the biggest one is PSP Dev. it's an open source SDK for PlayStation Portable development. And it's really mature. It covers a lot of functionality of PSP. So it has mostly everything that PSP is capable of. And PSSPP. It's an open source PSP emulator, and it's ported to a lot of different platforms and can run any PSP game. Okay, now let's talk about PSP dev. So for our quite a small game, we require very few things. We need 2D renderer, we need audio output, and we need user input, right? And PSP dev, of course, provides everything to cover our needs. So it has a graphic utility library. It's called GU, and the interface of GU is very similar to OpenGL. So of course it can do also some 2D rendering. It has user audio library, which provides 8 channels of audio output. So you see a limitation of 8 channels. We will talk about it a little bit later again. And it also has the controller kernel library that covers reading the status of the controller. So looks like we have everything. And using PSP dev directly provides a lot of flexibility, a lot of control. So we will be able to create another Burnout game, but that's a little bit overkill for us. And another point is that we wanted to have a safe net of having the host build. So for example, during the contest, something goes wrong. We have some really weird bug that we want to debug. And usually the debugging something weird on a real hardware or an emulator is a very painful task. So we wanted to have a safe net of host build, and it means that if we go that path of using PSP dev directly, we will build at the top layer of interfaces, hide PSP dev, implement something using OpenGL, OpenAL, and some controller logic. So it's a lot of work. And Bing, there is something similar to that, right? Looks like SDL can cover all our needs, right? And we are lucky because SDL has a support, a native support of PSP. So PSP is one of the supported platforms on SDL. Let's talk about SDL. So SDL stands for Simple Direct Media Layer. So it's a cross-platform library that hides complexity of window management, simple 2D rendering, audio input and output, keyboard and mouse support, and many other things. So it looks like PSP SDL provides everything that we need for our Ludo game. So let's talk about 2D rendering, the capability of SDL. So it has some drawbacks actually. SDL's rendering primitives can be split into big groups. One is to render rectangles, like rectangles, real rectangles on screen. And the other group is to render polygons. They call it geometry. And unfortunately, SDL doesn't provide the ability to set the model metrics. So it's okay for when you render a rectangle because it has only 4 vertices, right? So you can build a rectangle to render here, you can build a rectangle to render there. But when you try to render geometry, it means that if you prepare geometry to render on this part of the screen, and you want to render it over there, so you need to update every single vertex of this geometry to a new place. And on PSP it's even worse because PSP renders very fast from VRAM, and we store all our vertex buffers in RAM. So SDL copies them and then starts a rendering process. So we need to update them twice. But actually it went quite well because the majority of rendering in our game was with using the rectangles, and only rich text uses rendering of geometry. Then we start with using SDL2, and SDL2 provides a really nice way to output audio. It really nice. Let's say like that. So it provides a single channel audio output device, and also the huge library that mixes audio to give it to the output device. And we decided that we will implement our own mixture, because we don't want to have the low-level limitation of 8 tracks. So SDL's mixture can mix only 8 tracks, and I don't really like interface of the SDL's audio mixture, and because we can, and that's the main reason, and it's fun. So yeah, we have our own mixture, but we output to the SDL audio device. And the controller and joystick stuff was really straightforward. We just did some mapping from the keyboard to the PSP control to be exactly the same as an emulator. So anyone who runs on host, we will have the same experience as other person who runs on emulator. Yeah. So everything is ready for Ludo Dare. So that's how our game looked like before the contest. So you see that's actually a demo of everything that we integrated into our engine. So here is the rich text support, and that's the only component that uses geometry rendering primitive in the engine. No, not the only one that on this demo. I will talk about spine later. So there is an audio mixture. We also use the texture packer. That's a very famous and very commonly used thing in 2D game development. So it packs sprite animations into bigger atlases, and we created loader of this format and renderer of these animations and animation controller. Let's get back to rich text a bit. So there is a very commonly used format for bitmap fonts. And bitmap font is when for every character we store not a vector representation of this character, but a rasterized bitmap, and usually they are packed into bigger atlases, and BBM font provides the lookup table that okay, this symbol should be here in the bigger atlas. We use online tool that can convert TrueType fonts into BM fonts for format. So it just renders TrueType fonts into the bigger atlas with the symbols that you want to provide. It's not the ideal solution in terms of memory, but it works quite well because honestly I don't want to rasterize glyphs on a PSP. No, I think that it might be too hard. And yeah, the other component that we didn't use in our game, it's for 2D skeletal animation, and there is a really commonly used tool called Spine. It provides the interface for artists to create 2D skeletal animations that then you export into the Spine format, and they provide runtimes for different languages, and we use C++ runtime together with parts of the SDL runtime to load spine animations. So this guy, the trans, it's a spine animation. But we didn't use spine in the final game because our artist who can creates fine animations, didn't participate this time. Yep. And now I will let Ivan to talk more about modern stuff.
Yeah, okay. I will continue sitting. Okay, so we called our talk retro game development with modern tools, and I want to explain a little more which tools we use it in this development. Dmitry already mentioned SDL3, and we also use it Meson build system. It's quite modern tool, and GCC PSP Dev provide GCC, really recent one. So build system is really important, and PSP provide PSP Dev Kit, PSP Dev provide make or CMake support, but these tools are well known and really flexible. You can do whatever you want using make or CMake. But usually people want to focus on development of game or application instead of writing this extra scripts. And because of it, we decided to use Meson. So it's now very popular. Many open source projects moving to it, and I have used it before in my personal project, and we started it using in for Udum there as well. And benefits, yeah, it's easy to set up and simple cross compilation, support C, C++, and many other languages, works on everything, on Linux, Windows, macOS, and simple integration of test, formatters, linters, and whatever you want. And we use Meson a little differently. We utilize host target feature, which I believe mostly use it for creating building some building tools for cross compilation. But we use it to build our host version of game for host version of game in the same configuration as cross build to simplify our work. Yeah. And on example, you can see the simple build script for simple SDL application. So it's really simple. You don't need to do anything, almost anything. Only find your libraries and create a build. For cross compilation, we have PSP-Dev. You need just specify compilators, linkers, and whatever you use in cross build. So really simple. If you need to test, you just add your target, executable target to this test list, and then you can run them all using ninja test command. We enabled it in GitHub Actions, so it was our code was partly tested on every pull request. So if you want to add C-Lang formatter or C-Lang TD, you just put your config files to the root of the project, and corresponding build targets created automatically. Then you can run C-Lang format or C-Lang TD, whatever you want. And it helped us a lot to iterate fast, and it was really needed during this jam. We both use C++ in our work, and Dmitry already had some game engine written in C, a lot of helpful utilities and libraries to build games. And of course, we didn't have questions which language we will use for development of this game. So PSP Dev provides quite a modern GCC version. It was 15.1.1, I believe, in the version which we took for development, and it supports C, C++, and we configured our build system to use C++20, of course, because we are using modern tools for game development. Actually, I checked what we used from C++20. It's only designated initializer, but it's good. Finally, we can just copy C code from C to C++, and we used a new formatting library from C++20. Everything else, I believe, mostly C++11.
Only these two features were from C++20. Wow. Very modern.
Yeah, and after 3 days of development. We published our game for as PSP image, so people can run it in a simulator, emulator, and we didn't publish the host version of games, as Dmitry already described it. Nobody likes to run some on-GNOME application on the laptops and host process. So we will start looking how we can involve more people to run our game, because it's an important part of Gem. People should play games after they publish it. And we looked at WebAssembly, and we have learned that SDL3 supported out of the box, so we didn't have experience before with it, and we just followed the manual from SDL site and downloaded mscripting and added a new cross compilation, and it just worked. So of course it was some difficulty to inject all assets to this build. We need to fix main loop because in WebAssembly it works a little differently, but it's mostly straightforward. And everything described well in this manual. And Meson helped us again a lot, because it was very simple just to add new configuration. So yeah, and finally we got this game in browser, the same game.
So it's a PSP game running like everywhere in browser on what's that Asus? What?
Yeah, it's a Asus Ali.
Something on the Chinese
emulator
with an emulator on real hardware on hosting emulator on host. More than tools.
Yeah. So yeah, we're almost done.
Question?